Last thing you're gonna say to the bank. You're gonna walk to the bank and say get lost.
Are any of your parents like bankers? Do they work for a bank?
No.
Anybody in here's parents work for a bank? Oh, you do? That would be a good interview. You know, I like to do a project too where you interview somebody who works in math or science field. That would be a good interview. All right, listen up. This today we're gonna start. I'll put this on the agenda. Today we're starting chapter 7-6. And you know, after your test is a bell work quiz, so keep track of your bell work. So I just want to remind you before the project, we worked on rational exponents. It says rewrite as a radical, so I hope you did this. You put the little 3 down in the radical bar, and then you think, what to the third power is 125, and what is it? 5. Good job. This one would be the square root of 81. And you think, what squared is 81? 9. That's all your bell work is today. All right, we are going to take notes on chapter 7-7. I know. Sometimes in your classes you like don't do as much on early days, so it's so nice to go to math class and like do like a normal routine. I mean, normal routine.
Look at how perfect that is. Then why'd you look
All
at
right,
it?
the title of your notes. For your title, you want to write chapter 7-7. Whoa, don't do that. Geometric sequences. Chapter 7-7, geometric sequences is the title. Our goal today is to recognize sequences, to determine whether something is geometric or not, which we've already kind of done, talking about is this a linear table or is this an exponential table? But this is going to look a little more complicated. It's a little more difficult to recognize the pattern here, but mostly we're looking for patterns. So a geometric sequence is a sequence in which each term after the first is found by multiplying the previous number by a constant. So we've already gone over that. Exponential equations are shown using multiplication. The number we're going to call in this section R is known as a common ratio. You guys write this sentence down, the one I'm boxing. The common ratio can be found by dividing any term by its previous term. Because it's going to be more, like we're going to give you numbers that you're not as familiar with. In the graphs and the tables, you could look at them and say, oh, that's multiplying 3, or oh, that's multiplying 1/2, but these numbers are a little bit weird. So we'll look at 2 examples and then we'll do them. So example 1, determine whether the sequence is arithmetic, geometric, or neither. What you want to do is find the ratios of the terms. So a ratio is a fraction. So here we are, 21, 63, 189, 567. These are not numbers that are very popular. We don't really know. So we're going to do a fraction. 63 over 21, 189 over 63, and 567 over 189. Simplify all of them, and if you get the same number every time, you say, yes, this is geometric. So this is 63 divided by 21 is 3. 189 divided by 63 is 3. And 567 divided by 89 is 3. So again, nice to have a calculator here. Let's try. All right, let's do these 4 problems right now. Determine whether each sequence is arithmetic, geometric, or neither. So we're mostly interested in geometry here, but arithmetic means it's going up by addition. So in number 1, is it adding the same amount every time? So we can start by ruling out that it's not an arithmetic sequence. So then we will check ratios. So checking ratios means I'll put 2 over 1 and simplify it. I'll put 4 over 2 and simplify it. And I'll put 8 over 4 and simplify it. So when I put each term over the previous, if it equals the same thing every time, you say yes, geometric. And we know that the common ratio is 2. And so if we had to write an equation, it would be an exponential equation and the base would be 2. Looking at the next one, it goes from 9 to 14 to 6 to 11. So it's definitely not arithmetic because it's not adding every time. And because the number is going higher and then lower and then higher again, it's probably not geometric, but we can use a ratio to check. 14 over 9 doesn't simplify. And it's definitely not the same as 6 over 14. And that's definitely not the same as 11 over 6. So I'm going to say that this is neither geometric nor arithmetic. Now this fraction looks, do you guys think the fraction is yes geometric or no geometric? No? I'm going to get a common denominator. So with fractions, a lot of times it's a great idea to make a common denominator. So the denominator will be 12. So 3 goes into 12 4 times 2. So my first fraction with a denominator of 12 would be 8 over 12. My second fraction would be 4 over 12. My third fraction, 2 over 12. And my last fraction. Thank you. Okay, so I can see now we're going down 4 twelfths, down 2 twelfths, and then down 1 12th. So it's not arithmetic. Is it being multiplied by something every time? By 1/2, you think? Let's try finding a ratio. I better go to the big side over here. So, someone asked me in this class what a complex fraction was. How do we do ratios with fractions? So our first ratio, we would do 4/12 divided by 8/12. We would do 2/12 divided by 4/12. And last, we would do 1/12 divided by 2/12. We're going to simplify these complex fractions. Fraction over fraction is never a good idea. I'm going to write these horizontally. So these are just ratios, each term over the previous, just like number 1. We don't divide fractions, we multiply by the reciprocal. So I kept the first fraction, I changed this to a multiplication sign, I flipped this one. Now when I reduce this, you can reduce diagonally. We get 4/8, 1/2, which I heard some of you guys say. 0.5. Let's show that work again. So 2/12 divided by 4/12. That's the same as 2/12 times 12/4. Reduce diagonally. I don't think we have really done that this year. And we have 2/4, 1/2 again. Same common ratio. Same common ratio. You guys do the last one. All the way. Do a keep change flip. Multiply by the reciprocal for your bottom ratio. See that it's 1/2, and then doing this, yes, geometric common ratio 1/2. Ratios with fractions, not bad. Not bad. You only have one in your homework where you have to do the ratios of fractions. It's very similar. Very similar idea. All right, so 1/2 divided by, 1/12 divided by 2/12. Reduce diagonally, and we get the 1/2. So the answer to the question is yes, this is geometric, and I want you to now consider this an R value. R for ratio. There's a constant ratio here. When I put each term over its previous term, I get the same value, and that value is R ratio. Okay, number 4. I'm going to do this one up here on the screen. So what are we going to do to determine, well, let's test and see if it's arithmetic. This is +7, +7, and +7. So this is an arithmetic sequence. And now I'm going to test you with some vocabulary here. Back when we talked about arithmetic sequences, we called this the common difference. We said it was the D value. So in an arithmetic sequence, you have a common difference. In a geometric sequence, you have a constant ratio. Vocabulary. Okay. Let's find the next three terms. These directions tell us that it's geometric. So we're not questioning, wait, is this going to be an adding or multiplying pattern? It's given it's geometric. So I'm going to give you a step. Step 1 is to find R. By making a ratio. They should all have the same ratio because it's already told to us that it's geometric. So I'm going to do negative 216 over 648. Or I could do 72 over negative 216. You have my full permission to use the calculator, the fraction button in your calculator. Or what we're going to do is we're just going to divide the top and bottom and reduce. Like 216 and 648 might both divide by what? They're both even, so you can always start with 2. I think they might both divide by 4. 648 does divide by 4, so divide the top by 4. And we get negative 54. Divide the bottom by 4. We get 162. Man, I think this will reduce again. By 8 again? 54 divided by 8. Should have done 8 the first time, more quickly. So now we'll divide by 4 one more time. What's 54 divided by 4, Jake? No.
No, 54 divided by 4. Are you dumb?
No, that doesn't work.
16. You're bad.
54 divided by 2.
Literally just do this. Go here since you're on your phone a lot. And then type in 54.
Divided by 27. 1/3. Yeah, negative 1/3.
Basically, for explanation.
Only little people have to call out other people for being wrong. Small minds. Small minds.
I'm wrong.
But y'all, the
She just
calculator,
called you little.
most of your calculators, you have fraction button, you put it in there, hit enter to reduce it for you, you have my full permission. Okay? Alright, so R is 1/3. So now, to find our next three terms, we're going to multiply by 1/3. So step 1 was find R. Step 2, multiply by R to find the next three terms. So we'll do 72 times 1/3, which is the same as 72 divided by 3. Negative 1/3. This is negative. Yeah, same. Should always have the same ratio. 72 divided by negative 3. Negative 24. So negative 24 will be our next one. Then it's going to go positive. So negative 24 times negative 1/3 is going to give us a positive 8. So when your ratio is negative, your list is going to go positive, negative, positive, negative. And that's okay. Don't question that. Times negative 1/3 would be negative 8 over 3. So the answer is negative 24, negative 8 over 3. One more. Times negative 1/3 would be 8 over 9. times our number 6? Go ahead and do number 6. Find the next 3 terms. You're gonna have to use those fraction skills. I'll give you guys some time to talk about it, work it out together. Libby, what's the pattern of number 6?
I don't know.
Well, look, how does 25 turn into -5?
-30.
You guys, but we're not adding and subtracting anymore. We're multiplying and dividing.
Divided by. Oh wait, I know this one. Wait, so 25 to -5. It would be negative something.
Well, an easy way to figure it out is just to make your ratios. I'll put -5 over 25, the second number over the first number, and reduce it. It's -1/5. So each number is being multiplied by -1/5.
What? Everest. Miss, can I hurt him? I want to physically.
So we multiply by -1/5 each time. So we got to do 1 times -1/5 to get our fourth term, and it would be -1/5. And then we'll do it again. -1/5 times -1/5 would be +1 over 25. One more time. +1 over 25 times -1/5. -1 over 125. So the next 3 terms. -1/5, +1/25, -1/25. Negative, positive, negative. Thumbs up if you got it. You know that. Not calculator. Is it always on 220? Oh no. 222, 22. What's special about that? Anybody? And Groundhog Day?
Make your wish quickly. What a perfect day to have red district final.